The purpose of this lab was to calculate the mass of a black hole that is being orbited by a star. We did this by using observations of the star's motion to find the forces acting on our system, considering both parallel and perpendicular forces. In this case, the system was a star. We then used this information to calculate the mass of the black hole by Newton's law of gravitation. In the end, I found the mass of the black hole to be 4.37259 times 10 to the 31 kilograms. Here are the physics principles used in this lab. Newton's second law of motion, which is V final equals V initial plus F net divided by mass times change in time, the momentum principle, which is momentum equals mass times velocity, and Newton's law of universal gravitation, which is F net equals G times mass 1 times mass 2 divided by r squared, where G is equal to 6.67 times 10 to the negative 11. Here we have the mass of our star and the time step, which is equal to 1 day, both of which were given in WebAssign. Here's the CSV file given in WebAssign, which has the x and y coordinates of the star's position during the duration of the experiment, which our code then reads to make our model. Delta x and delta y equal the change in x and the change in y positions respectively from one point to the next. The x and y velocities are equal to the rate of change of each, or delta x divided by delta t for the x velocity, and delta y divided by delta t for the y velocity. We know from the momentum principle that momentum, here noted as p, equals mass times velocity. So we use this to find the initial momentum of the star by multiplying the initial velocity of the star by its mass, and the star's final momentum by multiplying its final velocity by its mass. The change in velocity of the star is equal to final velocity minus initial velocity, and the change in momentum is equal to the final momentum minus the initial. The derivative of the momentum, dp dt, is found by dividing the change in momentum by the change in time. Using Newton's second law, we know that F net is equal to dp dt. I then change p hat to equal the initial momentum vector divided by the magnitude of the initial momentum. The derivative of the magnitude of momentum equals the change in magnitude of the momentum divided by the change in time. dp dt parallel is equal to the derivative of the change in momentum times p hat. F net parallel is equal to dp dt parallel because of Newton's second law, as we discussed earlier. dp dt has both parallel and perpendicular components, so dp dt equals dp dt parallel plus dp dt perpendicular. By manipulating this, we get dp dt perpendicular equals dp dt minus dp dt parallel. F net perpendicular equals dp dt perpendicular, again by Newton's second law. The mass of the black hole is equal to the magnitude of F net times distance squared divided by g times the star's mass, where g is the gravitational constant, which equals 6.67 times 10 to the negative 11, and distance equals the square root of x idx plus 1 squared plus y idx plus 1 squared. I also adjusted the aeroscale for the visual representation of the running of the model. Before I ran my model, I edited it so that the black hole would be visible. I plugged in its given initial position and set its radius equal to 1.8 e to the 11, which I calculated as the magnitude of the initial distance between the star and the black hole. Here's what it looks like when I run my model. The yellow arrow is equal to the net force. The black arrow is equal to the net force parallel, which initially points opposite to the direction of motion but later points in the direction of motion. The blue arrow here is equal to F net perpendicular, and it shows us the direction of that the trajectory curves. The blue arrow always points to the center of the kissing circle. My code gave me a list of values for the mass of the black hole, which I then imported into Excel and found the average of. I found this value to be 4.37259 times 10 to the 31, and found this to be correct on WebAssign. What is the difference between dp dt and F net, dp dt parallel and F net parallel, and dp dt perpendicular and F net perpendicular? In this lab, we used F net and dp dt interchangeably. However, it is important to remember that though they are equal in quantity, they are not exactly the same thing. F net is the observed force acting on a system, while dp dt is the calculated changes in momentum as time changes. So, for example, F net could be gravity, while dp dt could be the changing momentum of a falling object as a result of gravity. Imagine the black hole was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Is it possible for you to find a value for the mass of the new black hole that is different from the mass you found for the original one? You would not find a different mass for the black hole because if the black hole's mass decreased or increased, the orbit of the star would either decrease or increase as well.